In this video, we're going to look at section 8.7, which is on pyramids. So just a couple terms that are going to be different. We have the vertex, which is at the top of the pyramid. Our lateral faces are all going to be triangles. And then we also have the altitude. So let me erase this stuff here, because I also have the altitude, which is the height of the entire pyramid, how far it stands off the table. And we have what are called lateral edges. I have the lateral face, but I have lateral edges here. And then there's this distance right here, which is called the slant height. That slant height is also the height or altitude of the triangle face. So when we do the surface area, we take the lateral surface area, and there's only one base, which is different than we did for prisms. So a regular pyramid is a right pyramid that has a regular polygon as its base. And for a regular pyramid, all of the lateral faces are congruent isosceles triangles. And for our formula here, we're going to have L equals 1/2 P times L, where this P is the perimeter and this L is the slant height. Here's Theorem 8.16. It says the surface area of a pyramid is the sum of the lateral surface area and the area of the base. So S equals L plus B. We know that L is 1/2 times the perimeter of the base times the slant height. And we know that for regular polygons, the area of a regular polygon is 1/2 AP, or 1/2 PA. So we can either look at the formula like this, just adding those two pieces, or if we use a little algebra and pull out the 1/2 P, we could also use this formula. So let's look at an example. So here's a pyramid that has a hexagonal base. We know that the surface area is the lateral surface area, L, plus the area of the base, which is B. We know that to find the lateral surface area, we take 1/2 times the perimeter times the slant height, and to find the area of the base, it's 1/2 AP. So let's work that out. I've got 1/2. Now I need the perimeter, so let's find the perimeter of the base. It's a hexagon, so there are 6 sides, and each one of those is 5 units, so the perimeter is 30. So I've got 1/2 times 30 times the slant height, which is 8, plus 1/2 times the apothem, which we can see from the drawing here is 2, times the perimeter, which we've already calculated, which is 30. So if I do a little bit of math here, if I take 1/2 times 8, that's 4, and 4 times 30 is 120. And then here, these 2's cancel, because that's like a 2/1, and I have a 30 there. So it looks like my total surface area is 150 square units. Okay, here's the next problem. This one is also a hexagonal pyramid, but I'm not given as much information. The only thing I'm given is the height and the length of one of the sides. So I can find the perimeter, because that would be 6 times 8, so the perimeter is 48. But I need a lot more information. I need the apothem, which I don't have, but I know I could draw it in right here. Here's my apothem. It goes from the center to the edge. That's my apothem, and I don't know what that is. I also don't know what the slant height is. So I'm going to have to do a little bit of work on this in order to get the information that I need. So here's that drawing again, and I've added some extra pieces so that you can see how we would work that out. As I had mentioned, we needed to find the apothem, which was this length right here. So what I've done is I've taken the area of the base, and I know I need this apothem, but I know that I have equilateral triangles, So this is 8, and the entire length of the side would be 8, but I'm only interested in half of it, so that's a 4. So you can see in this box, if I do the Pythagorean theorem to find A, I find out that A equals 4 radical 3. So then I go back over to this picture and I put 4 radical 3 on for the apothem, and you'll notice that when I do that, I'm looking at this right triangle right here. So this green triangle came from knowing the height of the pyramid. Here's the slant length, and here's that apothem, which we just discovered was 4 radical 3. So the apothem is 4 radical 3. The height is 16, so I can use Pythagorean theorem again to find out what the slant height is. When I square 4 radical 3, I get 16 times 3, which is 48. When I square 16, I get 256. So when I add those together and simplify the radical, I've got 4 radical 19. So now I'm going to take my formula for L, which tells me I need 1/2 times the perimeter times the slant height, and I can put in my numbers, and I get 96 radical 19. My base is 1/2 AP, so I need 1/2 times 4 radical 3 times 48. So when I come up here and simplify that a little bit, this 2 is going to cancel this 4, and I get 2 times radical 3 times 48. That's 96 radical 3. That's the area of the base. So I could actually change that to a capital B equals 96 radical 3. Now down here, what I did was I took the formula for the area of an equilateral triangle and calculated this area using that formula, and then multiplied it times 6 because there are 6 triangles. I showed you in class both methods, and either one is fine. You can either divide it into 6 triangles and then multiply that area times 6, or you could use 1/2 AP. But remember, these are only equilateral triangles if it's a hexagon for your base. Otherwise, you must use this formula instead. So to finish the problem, here's my L, and here's my B. You need to leave this written in this form unless you are putting it into a calculator, because these are not like radicals. Now let's remember that a pyramid is actually a cone. So as the number of the sides get larger, it looks more and more like a circular cone, and the perimeter approaches their circumference, and so the surface area approaches what we would expect for a pyramid. So instead of the perimeter times the slant height, we will take the circumference times the slant height. And for the base, instead of taking the perimeter, we're going to take the circumference. That's really the only difference. So here are our formulas for the surface area and the lateral surface area of a cone. It's still L plus B, which was the same thing that we had for a pyramid. Here you can see that the perimeter has been changed to a C because it's the circumference. Now I would like to change this a little bit more and say 1/2, because the circumference is 2 pi r times L. So this simplifies to just pi r L. And while we're at it, the B is a circle, so the area of the base is going to be pi r squared. So we could use the formula S equals pi r L plus pi r squared. So here we've got a summary of the formulas for pyramids and cones. And you can see that where we have perimeter for a pyramid, we've got circumference for a cone. But the basic formula for surface area is going to be the lateral surface area plus the base. So now let's look at an example. So let's find the surface area of this circular cone. I know that B is the base, and that is the area of the circle, so that's pi r squared. So B is going to be pi times 3 squared, so B is 9 pi. Okay, so now let's look at the lateral surface area, which is 1/2 times the circumference times the slant height. So for this problem, my circumference is 2 times pi times r, so 2 times pi times 3 times the slant height, which is 8. So 1/2 times 2, those are going to cancel, and I end up with 24 times pi. So my total surface area is L plus B. My lateral surface area is 24 pi. My base is 9 pi, so the total surface area is going to be 33 pi square units. This problem is a little more of a challenge because it says find the surface area of the silo with a conical top as shown in the diagram. So what we're looking at here is, first of all, I've got a circular cone. If the diameter is 16, that means the radius here is 8. I know that the height is 6 because of this number. So I end up with a right triangle that I can solve with Pythagorean's theorem to find the slant height here, because I know this is 6 and this is 8. So leg squared plus leg squared equals hypotenuse squared. So 36 plus 64 equals L squared. That's 100. So it looks like L must be 10. So I can put a 10 over here for my slant height. So now the lateral surface area of the cone, L is going to equal pi r L, which is pi times r, which is 8, times L, which is 10. So I have L equals 80 pi. That's for the cone. So now I need the lateral surface area of the cylinder. So for the cylinder, L is going to equal the circumference times the height, and the circumference, if you know the diameter, the circumference is pi times diameter, and my diameter is 16, and my height is 40. So altogether, my lateral surface area is 640 pi. So the total surface area is going to equal the area of the cone and the area of the cylinder. So 80 pi plus 640 pi, which is 720 pi square feet. Notice that we were not asked to include the bottom. We were not asked to include the bottom of this. So that's why we didn't include the 2B, because we also are not including this area right here. We're only including the area that is the conical top and the cylinder.